Okay, this is lesson 7.5, polynomials, and you're going to need your vocabulary sheet that looks like this. This should have been all filled out with the quotient of powers and things like that. We're focusing down here, we're starting at monomials. So this is lesson 7.5, and in your textbook it's page 476. We are going to have a lot of definitions today. So we just got done learning about all kinds of rules of exponents, what to do when you multiply and divide exponents. And that's important for us to manipulate expressions in algebra that have different exponents attached to the variables. Okay, so the first thing is the definition of a monomial. Now mono, the root or the prefix mono means one. So a monomial is an expression with one term. It's a one-termed mathematical expression. Now an expression is, or a monomial is a number, a variable, or a product of numbers and variables with whole number exponents. So here's some examples of monomials. Negative 7x is a monomial. 10xy is a monomial. 0.5x to the fourth. M and y is a monomial. So it can be any product of variables. We could even have various powers on those, but it's all one term because there is no addition or subtraction. Okay, addition and subtraction symbols separate terms. So not a monomial would be something like x plus y. X is a term, that's a monomial. Y is a term, that's a monomial. Together, when they're added, it becomes a binomial. Okay. Now, not a monomial is anything that has a negative exponent because that's not simplified or reduced. Or something like this is not a monomial because this does not, even though this has an x cubed, it's really in the denominator, so that really has a negative exponent. That's 2 times x to the negative third. So those are not monomials. When you put a bunch of monomials together, we call them a polynomial. So polynomial is a many-termed, it has many terms, and we're going to talk about finding the degree. The degree of a monomial is adding up all of the powers. So we're going to start really easy. If you had something like this, this is called a third degree. If you had an expression like this, we add up the powers. So 1 plus 1, this is a second degree. Okay. If you had something like this, just 5y, that would be to the first degree. If you had 5y to the sixth, that would be the sixth degree. So when you put these together, if you had a long expression like this, 0.5 x squared y plus 5xy plus 6. This has three terms, three monomials that are being added together. So to find the overall degree of this polynomial, you need to find the degree of each individual term. So this term right here, by adding up the exponents, do you see that this is a third degree? This one is a second degree. And this one is a constant, so this has a 0 degree. So the overall degree of this whole expression is you just look at the greatest one. So the greatest one here is a third degree. So we call this a third degree polynomial. So in your book, on page 477, right at the bottom of your worksheet here, I want you to do checkpoint 2A and checkpoint 2B right here. So pause the video, complete those, and then you can restart. Okay, in your textbook it says, the terms of a polynomial may be written in any order. However, polynomials that contain only one variable are usually written in standard form. So standard form of a polynomial is when you start with the greatest power and then you decline. You decrease in order. So something like this would be considered in standard form. And this only applies when you have one variable. So here we've got all x's. We start with our highest power and then you decrease. Now if we didn't have this term here, this would still be in standard form because it's in decreasing order. Okay? When it is in standard form, this number right here is called the leading coefficient. And that leads us right into the next definition here. The leading coefficient is the coefficient of the first term when it's in standard form. Okay, so while we're at it here, this is a polynomial. There are 4 terms to the polynomial. The leading coefficient is 4. It's in standard form because the exponents are decreasing. And if I were to ask you for the degree of this polynomial, remember you look at each individual term. This is a 3rd degree, 2nd degree, 1st degree, 0 degree. And the overall degree of the polynomial is whatever term is the highest degree. So this is a 3rd degree polynomial. Means it's to the 3rd power. Okay. So what I'd like you to do is pause the video for a minute, and in this box you're going to do 3A and 3B for the checkpoint, which is on page 477. It's going to give you a polynomial and it wants you to write it in standard form, identify what the leading coefficient is, and then I'd like you to find the degree. Okay. Alright, then we get at the bottom of page 477, we start classifying polynomials based on their degrees and the number of terms they have. So the first ones we're going to talk about is a binomial and trinomial. Those are based on the number of terms that they have. So bi means 2. So nomial means we have 2 terms. And remember, a term is separated by addition or subtraction. So examples of binomials would be 11x plus 5y, or negative 6x squared minus 9, where we have 2 things that we are adding or subtracting. Okay, trinomial means 3. That's where we have 3 terms. So 6x squared y plus 5x minus 7. There's our 3 terms. So terms again are separated by addition or subtraction signs. Anything over 3 we just call a polynomial. So there is no special name for something that has 4 terms. Anything that is over 3 we just say poly, which means many terms. Okay. Now, when we talk about these next 5 names, all of these terms have to do with the degree of the polynomial. So if something is 0 degree, okay, so for instance, anything to the 0 degree. Earlier we learned that that equals 1, and 1 is a constant. So 12, negative 24, any of these numbers are considered having a 0 degree because really if a variable was attached to it, it would be to the 0th degree because the number's just by itself. So constants are 0 degrees. We call something linear if it's first degree. And this is what you did a ton in pre-algebra. So 5x plus 9 is linear because it's to the first degree. 3y minus 10, first degree. Okay. 2x plus 3y equals 6. This is linear because it's to the first degree. Okay. The next one is quadratic. Quadratic is second degree. And after this chapter, we're going to spend the rest of the year dealing with quadratic expressions. But quadratics look like this. 2x squared plus x plus 9. It's a second degree polynomial. Y equals 4x squared. This is a second degree equation. Okay, you can have as many terms as you want. But as long as the greatest power is to the second degree, that makes it quadratic. Cubic is third degree, and we will hit that near the end of the year. So examples of cubic would be something like this. Even though this is many terms, it's a polynomial, it's still third degree because the greatest power is 3. So another example of a cubic equation. This is a real basic cubic equation. Third degree. And quartic is fourth degree. So anything to the fourth power. And you can have as many terms as you want. I guess I'm repeating numbers a lot. This is a quartic expression because it's to the fourth power. Now, we sometimes combine all of these together. So in this instance, if you had to identify this polynomial, you would identify it by its degree. So we would say it's a quartic, and by the number of terms it has. So it has 1, 2, 3 terms. So it's called a quartic trinomial. Okay. This one up here has 3 terms, so that makes it a trinomial. But it's to the second degree, so it's a quadratic trinomial. This one up here is to the first degree, so it's linear, and there's 2 terms, so it's a linear binomial. This one down here, the degree is 3, so it's a cubic, but since there's more than 3 terms, we just call it a polynomial, cubic polynomial. Okay, and that is your work today. Pretty much just checking. Oh wait, forgot something. Pause the video, and on page 478, I want you to do 4A, 4B, and 4C. So you can have a little bit of practice with naming those polynomials. Have a good night.